Okay, Algebra 2, Chapter 1.1. Today we're going to be going over mainly notations of intervals. And essential question for this section is, how can you determine the domain, range, and end behavior of a function? And that would be a rhetorical question, so we're not going to answer that today, probably in our continuation tomorrow. Okay? The key vocabulary we're going to address in this section is interval, domain, range, and end behavior. And today's portion, we're just going to concentrate on interval. What is the meaning of interval and how to describe what that is for a particular function. Okay? Now here's sort of a dictionary definition of what an interval is. A part of a number line without any breaks. And then it mentions a finite interval which has two endpoints which may or may not be included in the interval. So basically it would look like this. You could have this would be an example of a finite interval with two endpoints, right? Or another example would be the points may or may not be included. So if you went from like -3 to 5, and you might have, instead of an endpoint, you might have something that looks like this. Okay, the endpoint is not included. This is still at the bottom, a finite interval. Or if we made one of these an endpoint that actually exists, that is also an example of a finite interval. Okay, so that's finite intervals. Now, and basically here's an example of that. I already gave you one, so we can go right on here. And you would say, for this one, you'd say x is greater than -5 to 3 and less than 3 than or equal to 3, right? Or greater than -5 up to 3. So you can verbalize it a bunch of different ways. Okay, if an infinite interval is unbounded at one end or both ends. The ones we showed you earlier were finite intervals, so this is an example of an infinite interval. And this infinite interval is x is greater than -4. I mean, that's how you could say it verbally. How do you know this qualifies as an interval here? From the definition we gave. Why does this qualify as an interval? Okay, Connor says, correctly I might add, there are no breaks in this span of numbers, right? So therefore it is a single interval. So suppose an interval consists of all real numbers greater than or equal to 1. You can use that inequality, x is greater than or equal to 1, to represent that interval. So you can see that it's kind of economical, right? That inequality, this is called inequality notation. And we're going to go over that in a little more detail. Is that pretty familiar to you, inequality notation? Yeah, Jade. All right. And here are the types of notation that we're going to be using to describe intervals and domain and range of function. Now, what we're going to do in your development, your career as mathematicians, you're gradually going to more and more gravitate toward using interval notation, which you may not have ever seen, but you're going to see today. Number line notation, we've already looked at number lines today, right? So that's number line notation. Verbal, we've talked about that. Inequality notation, we just saw recently that x was greater than or equal to 1. That was inequality notation. So we're going to look at all of these and be able to go back and forth between them. Now, these are different types of notations, and a notation is a type of language or convention of describing things. So we're going to describe intervals. These algebraic methods of describing intervals couldn't be done until verbally they were articulated first. And so our advanced English language is what allows us to represent them in symbols. Okay? What I want you to do is draw out this scaffolding of this chart like this, and we're going to put down some different types of notation herein, okay? If you can do that, I'd appreciate it. Take a couple minutes. And this could be kind of like a go-to guide for you. Okay, now I'm going to give you some things to put in the little table here. And here they are. So I want you just to write everything in here, like, just take a little time to do that. Connor, you're a baseball player, I see.
Oh, yes, sir.
What position do you play?
Catcher.
Catcher? That's a tough position. You get beat up playing catcher. I couldn't do that. I could not do that. Okay, it looks like you're done or very close to it. So we're going to be looking at kind of the translation between these things for most of the rest of class today. Here's set notation, and of these notations here, which is the one that looks the strangest? Set notation. Yeah, I agree with you, Bryce. And accordingly, what we're going to do is we're going to look at what this really means. Okay, the way we would say this is we would say this verbally X, and then what does this little vertical line segment mean? The word such that. Okay. Then we would have X is greater than is that all? Greater or equal to, thank you, Jaden. Yeah, Victoria caught me at that 7th period, too. 1. Okay. Set notation is not as much used, but we're trying to get you ready for it when it is used. Where do you think set notation might be used? That you don't see it a whole lot, but it'll help you to know it when you see it. Where do you think you might see it? Any ideas where you might see set notation? Maybe when you're taking a ACT or SAT, something like that. Okay? And then you'll see it, and when you know what it is it going to be hard? No. But if you don't know what it is, it's hard, right? Or could be. But you see, this is a lot like inequality notation, when you think about it. Okay, interval notation. This is an example of interval notation. This one right here, this inward facing bracket means what? Greater than. If I could spell great, that would be nice. Greater than or equal to. That's what an inward facing bracket is. What is this parentheses here? Less than. And then between, you're going between -3 and 5.5. So that's going to be, interval notation is going to be your mathematician's language go-to most of the time, especially after this class. We're going to hang around doing a lot of set notation and stuff too, but gradually this is where you're headed. Okay? Questions on that? Ben, you got no questions on this? Okay. Okay. This is an example of interval notation. You'll see something like this. This is an infinite interval. This last one here, this is an example of a finite interval. Infinite interval here. This plus sign, it's in our book. In our book, they use plus infinity, but usually people just write infinity to mean plus infinity. Okay, and that's acceptable if you do that for me. Okay. This is another example of an infinite interval. We're going to get some examples of those pretty shortly. Inequality notation. Okay, and then you'll see it like this sometimes, but also you'll see it like x is greater than 1. So just say greater than or equal to 1 and less than infinity. So sometimes you'll just see it like this, but a lot of times you'll see it where you have both ends described. In a classical inequality notation, I think you'll see this on the right more, but they both mean the same thing. Okay? Here's an example of interval notation. Okay, I want to show you what this one looks like on a number line. Okay, it looks like 1. That's your number line version of this, okay? All right, let's look at the next thing here. We're going to go through examples in this table here, and I'm going to go through a couple of them with you, and I'm going to sort of take off the training wheels and let you do more by yourself. But here in inequality notation, you have x is greater than or equal to -3, but less than or equal to 2. So that's your inequality notation. Okay? Questions on that one? Next, set notation. And set notation can be very similar to interval notation. You have x such that x is greater than or equal to -3, but less than or equal to 2. And then you close the bracket like this. Okay? Very, very similar. Between those two, which one do you think I like better, inequality or set notation? Inequality, because it's usually more abbreviated. Not always. I'm going to show you a well-abbreviated set notation example pretty soon, but yes, I'm with you there. Okay. Now, interval notation. Here's our interval notation. We have greater than or equal to -3, comma, 2. That's interval notation. Do you like interval notation? Yeah, I like it. It's very economical, with just brackets, parentheses, numbers, and commas. And then a U also, but we'll talk about that later. Here we have arrows going both ways. So inequality notation could be like this. Oh, my pen is getting a little glitchy. Okay. So we have okay, is that right?
Should it be, is it not supposed to be equal to?
Yeah, so Jaden was right that you're not supposed to be equal to. Okay, so I'm going to have to undo those. And I deliberately made a mistake there for Jaden to catch it. Good. I'll do that sometimes. Or sometimes I'll do it undeliberately. You'll catch it anyway. And that's something to look for. If you're looking at a test and you see an answer choice that has greater than or equal to infinity or less than or equal to infinity, that's a what? That's a wrong answer. Just something to look out for. Set notation. Okay, set notation, we can just transcribe this inequality here. We put x such that x is greater than negative infinity, but less than infinity. Okay, you can do that, but sometimes you'll see another type of notation for that. I'm going to show that to you. Such that x, you have this like E looking thing, and this, all real. Have you ever seen notation like this before? Now Atlee in 7th period was telling me that this thing right here, she was introduced to that by Miss Tubbs. Have you seen that before, Gabby?
No, I'm familiar, but I was not
Looks
sure.
familiar. Well, Atlee, she remembered it from 7th period. Okay, so, and this thing means x is an element of. And this thing means all real numbers. And sometimes you'll see it just abbreviated as all reals too, or all real numbers. So just something to watch out for. Okay, next, in interval notation, that's going to be is that right? No, it's not right. Ben, what do we got instead, Ben?
Parentheses?
Yeah, parentheses. Okay? Okay, Jaden caught me on the other one, and Ben caught me on this one. Okay, gentlemen, you're exactly right. Good job. Okay, next. Now we have this exercise here, copy and complete the table. And write the finite interval shown on each number line. So I'm going to do that pretty quickly here, and then have you follow up on exercise. So on inequality notation, I'm just going to go like this, bracket, negative, no, that's interval notation, right?
Do you want us to write that table?
Yeah, write the table, but inequality notation would be x is greater than or equal to negative 3, but less than or equal to 2. And then set notation, x such that x is greater than or equal to negative 3 and less than or equal to 2. And then interval notation, we have bracket negative 3 comma 2 close bracket. I'll tell you that one problem that I had in my algebra career in high school was the understanding of inequality symbols. And I had a teacher who helped me out a lot with that by simply telling me that the thing you have to remember is the arrow always points to the smaller number. So if you remember that symbolic relationship, you don't have to worry about the verbalizing of greater than or less than as much. So just a hint. So anyway, that's the first column there. Do you have any questions about that? Okay. Let's go on to the next one. Now, this next one's very similar, except you have a what instead? You have this instead. Okay, and then otherwise, there's going to be similar. Down here, we're going to have negative 3 comma 2 bracketed on top, parenthesized at the bottom. We're going to have here in set notation x such that x is greater than -3, but less than or equal to 2. Okay, is that all making fairly good sense? You have questions about that? Marcus? Riley, you got questions about that? You're okay? Everybody's good? Okay. Let's go on here.
Are we supposed to do that?
This one here?
The one before. Yeah, we're supposed to fill that, you want us to fill that table in?
Right.
Okay, yeah. I
Yeah.
want to-
You almost done? Okay, you're almost done. Let me just hold it here for a minute. And I'll give you. What kind of intervals are these, by the way? Finite intervals. With endpoints. And the endpoints may or may not be actually included in the interval. Yep. Okay. Let's go to this one here. What kind of intervals are these? Yeah, infinite intervals. So we'd have our inequality notation. We would have, okay, negative infinity is less than x, which is less than or equal to 2. Now, in set notation, you'll often see an abbreviation of the inequality notation.
Teachers and students, pardon the interruption. Quick announcement before we dismiss. We still have about 8 minutes or so, we're not quite ready to dismiss, but I want to go ahead and say it. Students, we're going to dismiss for those that are parent pickup or drop off. We're going to dismiss you by the life skills room over there in that corner. Exit those doors, okay? Do not exit the main doors. We want traffic to continue to flow through the parking lot, and they're stopping right here at the.
So there's interval
main
notation,
entrance. So
right?
Please.
I'm just going to keep on writing through this if you don't
Over there by
mind.
those doors, by the life skills room, or kind of by the robotics classroom, back in that corner. Okay? Sorry for the late change, but we're always trying to make it quicker, easier, better, and more efficient as the traffic gets backed up pretty good on I-34. Thank you, and hey, great job today, everybody.
So there we have it, right? And then we have for set notation. Do you see how set notation can be an abbreviation that we just write it simply this way? We can just write our set notation this way. And finally, we can go like 2 to infinity, like this. Is that simple enough, you think? Okay. Reflect. Consider the intervals shown on the number line. Represent the interval using interval notation. And what that is, how would you write that with interval notation? So that would be it, right? Okay, pretty simple. And we're going to be using this for domain and range. We're going to probably start out about here tomorrow and consider things. What numbers are in this interval? All real numbers, right? Or we can write it like that if we want to, right? All real numbers. Okay. Any questions today on this? I think this is a good stopping point. We're going to just pick up for tomorrow on this. Thank you for your participation.